Good morning to Doctor. Today we are going to present about our assignment 2, which is the RoboCar. So we are from Group Messi, and we got 4 members, and my name is William Guerin E as a leader for this group, and our 3 other members is Husni, Taiwan Jun, and also Ati. So in this presentation, we have 4 sections. The first one is the concurrent design. The second one is the implementation of the code. And the third one is the testing and performance of the RoboCar. And the fourth one is the competition day. So now I'm going to pass to Taiwan Jun to present about the concurrent design.
I'm Darrenjin. Now I will present the concurrent design in our projects. So design conclude a few information which include the task scheduling, task communication and synchronization, sensor integration. So for the task scheduling, it could include the determine the order and timing of task execution and use real-time scheduling algorithm like rate monotonics or alias deadline first. And for task communication and synchronizations, it includes establish inter-task communication mechanisms and ensure synchronization to avoid conflict. Lastly, for sensor integration, it includes integrate various sensors like LiDAR, cameras, radars for precisions, currently process sensor data to make real-life decisions. So for the task scheduling, it can include what the robot to do, such as left turn, right turn, and then etc. etc. For task communication, it includes that robot how it communicate within the system, which is the first task, which is the second task, which is the third task, to avoid conflict. For the sensor integration, our robot have integrated with such as a sensor of the black and white lines, obstacle sensors, and then light sensor. That's all from me.
I'm Mati Padiashi, so I'll be explaining the implementation for our assignment. So firstly, we move on to the code overview. So for the code setup, we'll be using the Arduino IDE for coding and AVR Studio to run the code and to add it to the RoboCar. So we'll be using the UCOS 2 real-time operating system. And in this code, we have 4 functions: the check collision function, control motors, and navigation function, and task start function. So first, concurrent task, we're going to look at the collision detection. So it will be the check collision function. So it checks if the robot it's about to collide with an obstacle using the proximity sensor. So once the sensor is triggered, the RoboCar will detect the obstacle and it will change the state to 1, which means it either stops or it moves a particular direction sign. So next, the controlling motor function. For this task, the controlling function, the task is responsible for adjusting the speed of the RoboCar based on the assigned value. And we have the navigation function, and this one is the main function in the code. So for this implementation, it uses the concurrency. So we have the sensor from the data from the sensors, and the states of the robot is adjusted according to the given conditions. I can see we have the light sensor condition, the obstacle condition, and the line sensor condition. So these 3 sensors will run based on the condition given. We have 9 switch cases for the line sensors. To how the concurrent design is implemented in the coding. So we can see here firstly the task scheduling. We have all the tasks defined here with the priority. Handles the task scheduling, and it assigns different priorities according to the given defined value here. So the scheduling policies is priority based and primitive scheduling, and the highest priority task is executed first. Next, for the task communication and synchronization. For the task communication, we can see the code communicate via the shared variable. In this check collision function, for example, we can see the task is updated to my robot obstacle, this variable here, based on the sensor input given by the proximity sensor. And then the navigate is triggered to the navigation function where navigation function checks the my robot obstacle parameter and shares the state with the task to the ordered state. And for the synchronization, we have this OS time delay parameter here. It uses to add a delay to the robot. So it will add a delay. For example, here it's written 100 millisecond. So next we have the sensor integration. For this concurrent design, the check collision task function is used to check the proximity sensor data to check for the obstacle. The robot speed are adjusted in the control motors according to the condition assigned, task based on the robot state. So the navigation function guides the robot based on the sensor input, like obstacle and the light sensor. So that's all for the implementation. I'll pass on to Husni for testing and performance.
Okay, so thanks to Ati for his part. So now I'm Husni Musharraf, so we will present on the testing and performance. So the first one is turn right of the second checkpoint. So we declare a counter where if 4 times the robocar keeps reverse back and forth on the same place, it triggers a sharp 90-degree turn. So this is because there is one part where it becomes a dead end. So here's how it looks like. So you can see, once it detects 4 times to the counter, so it turns right and goes back into the track. Oh. Okay, so the second one is the obstacle detection. So we declare a function where if it detects an obstacle, it will turn slightly to the right and immediately go forward at full speed again until it detects the line again. So here how it looks like. As you can see, it has a little bit turn to the right and goes back into the line. So the last one is it turn left on light sensor. So we declare a function where it will turn left if it detects a certain amount of light. So here's how it looks like. So basically, since this one is a little bit brighter than the one we have tested in the lab, so it has a little bit of error there. So that's why it's not working properly here. So yeah. So on the competition day, we were super thrilled to be able to compete with other teams because we get to test what we have code for about 2 or 3 weeks together with our team to see what other teams are performing. And sadly, but we are only able to pass up to the third checkpoint, which is after the obstacle detection. So here's how the event looks like. So yeah. That's it from us. Thank you.